everyone. Now, this is one of the questions I dealt with one of my home lesson learners. So most times, after having these discussions with them, I try to just record them and post in case there be any learner out there who may have a bit of challenge understanding some of these topics. They can learn one or two from. So this is another question on motion, but this is motion on an inclined plane. It's a bit tricky, even for grown-up adults sometimes, Let's see how we can solve this. We just have this sketch, and we're told that this object, let's call it object O. This object here is going to roll from A to B along an inclined plane. And the distance from A to B is 10 meters. And this inclined plane is inclined at 30 degrees to the ground, the horizontal. And we're asked to find the time, how long it will take to move from A to B. Now, there's a little trick I'm going to show us here. In another video, I will explain how you can derive this structure I'm going to make now. So when you have inclined plane, most of all, you see that you are going to resolve acceleration due to gravity, which is a vector, into components horizontal and vertical, or you are going to resolve weight, another vector quantity, into horizontal and vertical components, depending on if you are considering motion or forces. So because we are considering motion here, we are going to resolve acceleration due to gravity. Now, where learners have challenges, where to locate the angles and how to resolve. Now, the little trick I'm going to say is this. Anytime you have inclined plane, draw another inclined plane. In this one, don't use these values you have here. Just tell yourself, you see this 30 degrees inclined here, bring it up here. Just put it up, that's all. Then this inclined plane is going to represent acceleration due to gravity, G. If it is under force, it's going to represent weight. Now, this is going to be the vertical component of gravity, and here is going to be the horizontal component of gravity. Just use this trick. Whatever the angle the inclined plane is inclined at, take it up to this place. Then the hypotenuse should be either the gravity or weight. Then you resolve into components. So you're going to have vertical components using SOHCAHTOA. This is adjacent over hypotenuse, right? That should be cos 30. Opposite over hypotenuse should be G sine 30. Now you've resolved. The next thing is, what do you need these components for? Okay, now go back to this question. For you to understand what you're going to do, assume this vertical plane is a horizontal line. Okay, just assume it's a horizontal line. So the object to move horizontally, you are going to use the horizontal component of gravity in your equations. Remember, we have S, which is distance, as 10 meters. Since the object started from rest at A, initial velocity is 0, right? And we have acceleration, which is going to be the horizontal component of gravity as G sine theta. Now look here, we have S, we have U, we have A. If you are looking for T, which of the equations of motion can you use so that only two will be the unknown? I know that there's equation of motion stated as S equal to UT plus half AT squared. My S is known as 10. I put it in. U is 0 multiplied by T, which I'm looking for. Of course, this is 1 unit, right? They have plus half A Remember, sorry, this is half gx t squared. So what is our gx? G sine theta. G is 10 times sine 30 times t squared. So half 10 equal to 0 plus 2 divided 10, 5. 5 sine 30 t squared. Now this is 10 equal to, we'll take away the 0, 5 times sine 30 is half t squared. So half 10 equal to 5t squared over 2. When you cross multiply, you have 20 equal to 5t squared. So when you divide both sides by 5, you have 5t squared over 5. So this goes, here is 4 equal to t squared. Since we're looking for t, all we need to do is take square root of both sides. You see that your t is 2 seconds, and that's it.